Okay, I'm back. I need you to confirm that you can hear me. I'm back, and I'm you know I'm trying to finish this, hopefully. So we left here where we execute from 105 160, and we have all these instructions, all these words in the cache. So we have 280 hits. This is because from 105, including 105 to 100, including 160, is 60 words, 56 accesses, and that is 5 times because we execute this 5 times. So it's 280 hits. And after that, 161, the CPU executes the instruction at 161, 62, 63, and this means it's 0 misses and 3 hits because up to 163, all these words are already in the cache, and then the processor needs 164, which is not here, is not in the cache. 164 is not here in the cache. 164 is in um, um, block number 41. Block number 41, which maps at 41 modulo 8. That's 1. So it's here. So yeah, I'm going to put it here. Some red. I don't know. So is no do 5. Okay, and it's because this is the least recently used, right? The competition is between this guy, one indexes, right? This guy, this guy. The least recently used, obviously, is this one. So it's going to be 164, 167. And then it's the same thing for, so it means that I have one miss and then 3 hits. And then 168, 171. This is in 42, in block 42, which maps at index 2, obviously. So yeah, that's 5 here, and 168, 171. 168 is a miss, but 169 and 170 are 2 hits, and then it stops. Okay, now let's count all these hits and misses. So the number of misses are 1 plus 31, 32, 33, 34, 35, and 36. So we have 36 misses. Okay, and let's see the hits. So this is time 3, so it's 93, 94, so it's 93, 94, 97, 97, 100, 105, so it's 105 plus this big number 280, which means it's 5, that's 8, 385 hits. So the hit rate, which we are asked to compute, is 385 divided by the number of accesses, which is 36 plus 385, and that is 1, 12, and 4. And let's see about this. Let's compute calculator. Compute this hit rate. So it's 385 divided by 421. That's 91.45%, and 91.45% approximated. Now let's answer also to point number C, and that is the average memory access time. It is simple. The memory access average memory access time is a weighted access time. That is the time of access when the information is found in the cache is multiplied with the hit rate, obviously, right? Plus the time required for accessing information when there is a miss. And when there is a miss, you first spend, as the processor spends the time of access. Why? Because it needs to see if the information is in the cache or not. So it has to read the tag. But this, cache read, because reading the tag is in fact a cache read, requires the time of access plus the miss penalty, and that is the time required for bringing 4 words, which is 1 block in the cache, right? Times the miss rate. But when you open up this parenthesis and you have time of access times hit rate plus time of access times miss rate, and you have this common factor, time of access, and in the parentheses you'll have hit rate plus miss rate, which adds up to 1. So you will have the time of access plus the miss penalty times the miss rate. Now, which is the miss rate is, obviously, we know this. That's 5, 8, 8.55%. This is the miss rate, right? So this is with this stupid idiot. I can go. Can I go? No. Yeah. So this is the time of access. That's 20 nanoseconds. 20 nanoseconds plus the miss penalty, I guess, is 500 nanoseconds, if I remember it correctly, times 0.0855. So this will, yeah, it's 500 times 0.0855, right, plus 20, and that is 62.75 nanoseconds, and that is the average memory access time. So that is all for today. It was a bumpy road today, mainly because of this OneNote stuff. This newer version of OneNote apparently works better. I don't know why, but yeah, this. Okay, so we'll stop it here, and hopefully, if you're still here, you can, ask me questions on Discord.